All right, this is fourth grade, Module 1, Lesson 10, and in this lesson we're going to continue rounding, and we're really just going to be practicing rounding. The difference is we're going to be doing a lot of real-world applications, and in a large part, students get to choose which place value makes sense for them to round to for that given problem. All right, so here it says round this big old huge number to the nearest, and then we have some options. So the idea is, teachers and parents, at this point in the game, we really want students to be able to just look at that number, 800, in this case 845,001, and we're going to do it 3 different times. So I'm going to write that 3 different times, all right? And then be able to just kind of look at the number, recognize the place value, and round it without really drawing out that number line. But they might be visualizing the number line, and that's exactly the point, right? So first we're going to round to the nearest thousand. So we need to know ones, tens, hundreds, thousands. So here's our thousands place, and we're going to look over here. And does this stuff make us closer to 845,000 or 846,000? And we can see that it bumps us to 845,000. It's just barely above the 845 limit. And again, we're going to round to the 10,000s. So ones, tens, hundreds, thousands, 10,000s. So it's the 4 that's the 10,000s, and we're going to look all the way over here. And all this stuff, does that tell us to round down to 840,000? Or does that tell us to round up to 850,000? And we can see that, oh, this is just barely above that midway point. And so we know it's going to round up to 850,000. And then the last example, rounding to the nearest 100,000. So we've got ones, tens, hundreds, thousands, 10,000s, 100,000. So here's our 100,000s. We're going to look at all this junk. We have to ask ourselves, does that cause our 100,000s to round down to 800,000 or round up to 900,000? And that 445 tells us, oh, we didn't quite meet that midway point. So it's going to round down to 800,000. So what's really cool, parents and teachers, is we want students to see that the same number can round to 3 different values depending on the place value that we round it to. And that's a really useful tool in real life. So we're going to do 3 word problems, and I'm going to go pretty quickly. So parents and teachers, you may need to pause and rewind the video numerous times in order for your 4th grader to really understand what's going on. So it says in the 2011 New York City Marathon, we've got this many men and we've got this many women who finished the race. About how many men's shirts were given away, and then about how many women's shirts. So we've got 29,867 men, and we've got 16,928 women. All right, now it just says about how many shirts were given away, so it allows the students the choice to decide where to round to. Hey, personally, as a math guy, I like to do what I call front-end estimation, and just whatever is the number, in this case, let's look at 29,867, I just round to whatever is that front number, and in this case, it's the 10,000s place. So are we going to round down to 20,000, or are we going to round up to 30,000? And in this case, we're going to round up to 30,000 men. And then in the same way, I'm going to look here, front end, and that's in the 10,000s place. So does this extra stuff cause us to round down to 10,000 or round up to 20,000? And it causes us to round up to 20,000. So parents and teachers, I'm going fast because at this point we're really kind of just practicing. So make sure, if you need, pause and rewind. And there's our quick answers for this problem. In part B, it says in the 2010 marathon, 42,429 people finished the race and received a medal. Now, before the race, the medals had to be ordered. If you were the person in charge, would you have ordered enough medals? And the idea for this, teachers, is to say that, well, some students might say, well, if we did some front-end rounding, and if we looked at our tens, 10,000s, and said, well, this stuff tells us to round down to 40,000 medals. Well, in this case, rounding down would have been a bad idea. And so even though this is the correct rounding down, we would be short a bunch of medals. So in this case, we may have to round up, even though the standard algorithm says not to. So maybe we wouldn't round down. Maybe we would say, well, let's just call it 45,000 medals. Or maybe we would say, well, let's be on the safe side and order 50,000 medals. So this is a really kind of a neat question that shows how sometimes the math world and the real world don't always perfectly line up. And then the last problem for this video. In 2010, we had 28,357 of the finishers were men, and 14,072 of the finishers were women. About how many more men finished than women? All right, so men, let's start with men. So we have 28,357, and if we want to do, I really like that front end estimation. So here's our front end, and that's in the 10,000s place. So does this cause us to round down to 20 or round up to 30,000? And it causes us to round up to 30,000 men. And then the women, we have 14,072. And again, let's do that front end estimation. And in here, here's our front. And so that's in the 10,000s place. So does all this stuff cause us to round down to 10,000 or round up to 20? And in this case, it causes us to round down to 10,000 women. And this is really rough, but that's okay. So about how many more men than women? Well, about 20,000 more. Now, boy, if you go back and you look at our numbers, man, that doesn't look, our estimation is kind of not really solid, right? That's because when we rounded the men, we rounded up, but when we rounded the women, it rounded down, and it made our difference get even bigger. But that's okay, especially, man, down the road when some of our students are astronomers and they're studying the solar system and they're studying planets, being off by 20,000 of something one way or the other is nothing. All right, so that wraps up 4th grade Module 1, Lesson 10, using place value understanding to round multi-digits numbers in real-world problems.